keto group plus carboxylic acid group. Example CH3 C double bond O CH2 CH2 CO OH. React with zinc amalgam HCl. React with zinc amalgam HCl. So here you see the keto group is there and COOH group is there. So generally we know very well the keto group is carbonyl group is reduced, but here these acidic groups, means the sensitive acidic groups, may not be affected. Only the C double bond O group is converted into CH2. The product is CH3 CH2 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 COOH. So there is no effect in carboxylic acid group. So this is when keto group plus carboxylic acid group will be present. Only the carbonyl group is reduced, but there is no effect on carboxylic acid group. Remember students. Then fourth, keto group plus nitro group. Keto group plus nitro group. So this is a keto group and this is a nitro group. So these two groups means when keto group and nitro group will be present. So react in presence of react with zinc amalgam HCl. So we know very well the C double bond O carbonyl group is reduced, and also here the NO2 group is changes into NH2 group here. So this group changes into amine and this group changes into alkane. Okay, so if any nitro group is substituted on benzene ring, generally when we are treating zinc amalgam HCl, the NO2 group is converts into NH2. So we obviously the C of carbonyl group is reduced. So the product is CH2 CH3. Here the NO2 converts into NH2 group. So the nitro group is converting into, remember students, NO2 group is converts into amine group, and we know very well the C double bond O group is converts into CH2. Okay, so this is when keto group and nitro group will be there. The keto and nitro groups are converts are reduced, but here keto group and all carboxylic acid group, only the carbonyl is reduced. There is no effect on carboxylic acid group. So we will see 1,3 diketones. So the example is C2H5, C double bond O CH2, C double bond O CH2, C2H5. React with zinc amalgam HCl. So what is our possible product is C2H5, C double bond O CH, CH3, C2H5. So this is a product. So means 1,3 diketones, one carbonyl is reduced and the remaining carbonyl group is as it is. So we will see the mechanism of this reaction here. The radical mechanism is takes place here. C2H5 C double bond O CH2, I'll write like this, C double bond O CH2 C double bond O C2H5. React in presence of H plus, C2H5 C double bond OH plus, it donates pair of electrons to the H plus, CH2 C double bond OH plus C2H5. Here react with zinc undergoing oxidation process. These two electrons here, it converts into, mean the double bond is shifted, the pi bond is shifted to oxygen. Here also same. So these two electrons shifted to these two deficient carbon atom undergoing a radical type of mechanism to form product as C2 C2 H5 C OH CH2 C OH C2 H5. So the radicals are here. These two radicals. So these two radicals undergoing cyclization, so means converts into the three-membered ring C2H5 C CH2 C C2H5 C2H5 OH OH react with H plus, react with H plus, donates to hydrogen atom C2H5 C CH2 C C2H5 OH OH2 plus. In this step, it leaves water molecule. It leaves water molecule and this carbon gets deficient. So therefore here this bond is shifted to here. Then this carbon gets a positive charge. So therefore here, so it leaves H plus. So it leaves water molecule and also it leaves H plus. Then we will write the remaining compound C2H5. Here this bond is shifted to here. This bond is shifted to here. So this carbon is having CH2. Here it shifted to, bond is shifted to here. It becomes a C double bond O C C2H1. So again react with zinc and HCl under acidic condition. So the HCl hydrogen is shifted to here. So therefore here C2H5 C double bond O CH CH3 C2H5. So this is our product. So this is very important mechanism in Clemmensen reduction. So this is also very important for aromatic type of compounds. Means ring contraction is possible. We will see that type of mechanism also. So we will see one more example in 1,3 diketones case. CH3 here, C double bond O, C double bond O, react zinc amalgam HCl. React zinc amalgam HCl. The product is a 6-membered ring is converts into a 5-membered ring. A 6-membered ring is converts into 5-membered ring, and so this is product. Means here the 6-membered ring is converts into 5-membered ring. So this is the product. We will see the mechanism for this reaction. Mechanism for this reaction. So first we will write CH3, C double bond O, here also C double bond O. So 1, 2, 3, 1, 3 diketones. React with the same, already we have seen previous example. React under SD condition, H plus CH3. So these carbonyl groups are converts into OH plus. Here also converts into OH plus. Right. So next react with zinc undergoing oxidization. So this zinc we will write in like this. So here the bond is shifted towards more electronegative oxygen atom. At the same time, so these pair of electron shifted to this carbon atom and this carbon atom undergoing radical process. CH3, it becomes OH. Here we have radicals here. So these radicals are combined to form cyclization. CH3. Here you can see. So this is OH. Here also OH. So means 1, 3 carbon atoms undergoing cyclization process react with again H plus. OH is converts into H2O. OH is converts into H2O. This is OH2 plus, and this is OH. This is OH. Next, what will happen in this reaction? It leaves water molecule. So this carbon gets positive charge. So therefore, here the bond is shifted to here. So this carbon gets positive charge. So therefore here, so this bond is shifted to here. So therefore here, so it leaves water molecule and H plus. So the remaining product is CH3. So this is converts into C double bond O. Here this converts into C double bond O. Sorry. So here it forms a 5-membered ring. So this carbon CH2 is converts into CH2. Then the same process again zinc and H plus. The product is CH3, C double bond O, CH. So this is the product. So here a ring contraction is takes place here. Ring contraction. Ring contraction. So therefore, a six-membered ring, a six-membered ring, converted into five-membered ring. So a six-membered ring is converts into five-membered ring. If five-membered ring will be there, so during the ring contraction process, five-membered ring is converted into four-membered ring. So that is the process. So in ring contraction process, ring expansion and ring contraction will be there. So here ring contraction is possible. So due to the ring contraction process, a six-membered ring is converts into five-membered ring. So thank you.